Graphing quadratics from factored form. Factored form is called intercept form because we begin by finding the x-intercepts and then proceed to find the axis of symmetry, the vertex, and other points. Before beginning, you need to understand the zero product property. Anytime two factors multiply to make zero, one of the factors must be zero. We can solve problems that look like this by using the zero product property. Since one of the factors must equal zero, we can set each factor equal to zero and solve. We will always get two answers. Now let's try some examples. Set each factor equal to zero and solve the two equations separately. The solutions are x equals 2 or x equals -4. Either of these values is a solution because either value will make the equation true. Pause the video and try this one yourself. Now that you have tried it, check your work. Set each factor equal to 0 and solve. The two solutions are x equals 5 or x equals 1/2. In this example, the factor -1/2 does not affect the procedure. Only factors that can be set equal to 0 can be used to solve the equation. Set x plus 7 equal to 0 and x plus 6 equal to 0. The two solutions are x equals -7 and x equals -6. Now pause the video and try the next example yourself. Now that you have tried it, check your work. Ignore the factor 2 and set just for the factors x minus 5 and x plus 3 equal to 0. Solve both equations. The solutions are x equals 5 or x equals -3. When graphing parabolas in factored form, we start by finding the x-intercepts using the zero product property. For any x-intercept, the y-coordinate is 0. Thus we can solve 0 equals x minus 3 times x plus 1. Set each factor equal to 0 and solve for the x-intercepts. The first x-intercept is 3, 0. The second x-intercept is -1, 0. The axis of symmetry will be halfway between these 2 points at x equals 1. It is also possible to find the axis of symmetry by adding the x-intercepts together and dividing by 2. 3 plus -1 divided by 2 equals 1. The axis of symmetry is x equals 1. To find the vertex, plug in x equals 1 and solve for y. Y equals 1 minus 3 times 1 plus 1 for -2 times +2 or -4. The vertex is 1, -4. This parabola opens upwards, so it has a minimum at y equals -4. The y-intercept is found by setting x equal to 0 and solving for y. Y equals 0 minus 3 times 0 plus 1 for -3 times +1, which equals -3. The y-intercept is 0, -3. The domain, as usual, is all real numbers. The range is y is greater than or equal to -4. To find other points, use the same method we've used before. A in this case is 1. 1 times 1 is 1. Go over 1 and up 1. 1 times 4 is 4. Go over 2 and up 4. 1 times 9 is 9. Go over 3 and up 9. 1 times 16 is 16. Go over 4 and up 16. Draw a smooth curve. Let's look at another example. In this case, a is -1, so the parabola opens downwards. Solve for the x-intercepts. The first is 4, 0. The second is -2, 0. Halfway between these 2 points is the axis of symmetry at x equals 1. To check this, add the x-intercepts together, 4 plus -2, and divide by 2. You get 2 over 2, or 1. The axis of symmetry is x equals 1. To find the vertex, plug in 1 for x. For y equals -1 minus 4 times 1 plus 2. -3 times +3 is -9, or +9. The vertex is 1, 9. To find the y-intercept, plug in x equals 0. For y equals -0 minus 4 times 0 plus 2. For -4 times +2. For a -8, or +8, the y-intercept is 0, 8. The domain, as usual, is all real numbers. The range is y is less than or equal to 8. The maximum is y equals 8. To find other points, use a. A is -1. -1 times 1 gives -1. Over 1 and down 1. -1 times 4 is -4. From the vertex, over 2 and down 4. -1 times 9 gives over 3 and down 9. -1 times 16 will be over 4 and down 16, which is off the graph, so draw a smooth curve. Now pause the video and try this example yourself. Now that you have tried it, check your work. A is negative, so this parabola opens downwards. Solve for the x-intercepts. The x-intercepts are -7 and -5. The axis of symmetry is halfway between at x equals -6. To find the vertex, plug in x equals -6 and solve for y. Y equals +3. So the vertex is -6, +3. The maximum for this parabola is at y equals 3. To find the y-intercept, plug in x equals 0 and solve for y. The y-intercept is -105, which is far too big to fit on this graph. The domain is all real numbers. The range is y is less than or equal to 3. To find other points, use a is equal to -3. Over 1 and down 3. Over 2 and down 12. The other points are too far away to fit on the graph. Draw a smooth curve. Pause the video and try this one yourself. Now that you have tried it, check your work. A is positive, so the parabola opens upwards. The x-intercepts are 1 and 7. The axis of symmetry is x equals 4. Plug in x equals 4 to find the vertex. The vertex is 4, -3. The minimum then is y equals -3. Plug in x equals 0 to find the y-intercept. The y-intercept is 1/3 times 7, which is approximately 2.3. The domain is all real numbers. The range is y is greater than or equal to -3. To find the other points, use a equals 1/3. 1/3 times 1 is 1/3. 1/3 times 4 is approximately 1.3. 1/3 times 9 is 3. 1/3 times 16 is approximately 5.3. Draw a smooth curve. This equation is in standard form, not in factored form. It can be graphed from standard form, but we are going to review factoring and graph it from factored form. Two numbers that multiply to make 12 but add to make -8 are -2 and -6. The factored form is x minus 2 times x minus 6. The intercepts are 2, 0 and 6, 0. Pause the video here and finish this one yourself. Now that you have tried it, check your work. The axis of symmetry is x equals 4. Plug in x equals 4 to find the vertex. The vertex is 4, -4. The minimum is y equals -4. Plug in x equals 0 to find the y-intercept. The y-intercept is 0, 12. The domain is all real numbers. The range is y is greater than or equal to -4. To find the other points, use a equals 1. Draw a smooth curve. To factor this function, notice that there is a greatest common factor of 2. Factor out 2 for 2 times x squared minus 6x plus 5. Now factor the inner trinomial. Find two numbers that multiply to make 5 but add to make -6. These are -1 and -5. Now we have 2 times x minus 1 times x minus 5. Now pause the video and try the rest yourself. Now that you have tried it, check your work. The x-intercepts are 1, 0 and 5, 0. The axis of symmetry is x equals 3. Plug in x equals 3 to find the vertex. The vertex is 3, -8. The minimum is y equals -8. The y-intercept is 0, 10. The domain is all real numbers. The range is y is greater than or equal to -8. To find the other points, use a equals 2. Draw a smooth curve. Now pause the video and try this last one yourself. Now that you have tried it yourself, check your work. A is negative, so this parabola opens downwards. First, factor the function. The x-intercepts are -1, 0 and -3, 0. The axis of symmetry is x equals -2. Plug in x equals -2 to find the vertex. The vertex is -2, +2. The maximum is y equals 2. The y-intercept is 0, -6. The domain is all real numbers. The range is y is less than or equal to 2. Use a equals -2 to find further points. Now draw a smooth curve. Please review these notes as you complete your assignment.